Okay, so what we're going to do is we're going to work through the different methods that we're going to be using in this course to deal with the indeterminate form. So, number one, first method is the factor ring method to determine, not to determine, but to deal with this 0 over 0 form. And we've already done this. You've seen me do two examples with factoring. So we'll start off with evaluate each of the following, and I'm just going to do examples for all of these. So, and I'm not going to stop and talk to you about it. I'm just going to do them, and you can copy them down. If the studio or the audience has a question, you can ask me, say, sir, stop, but let's start going. So the limit is x minus 2 over x squared minus 4. So I'll give you a second to copy that down, and I think what I'll do is I'll write the second one over here while you copy that. And this one's going to be the limit as x approaches 1 of 2x squared plus x minus 3 over x squared minus 1. And I'll have two more to do, but that's good to start with. So, first of all, the first thing you do when you walk into a question like this is you always try the mega property. Because if the mega property works, you're done. This is a polynomial, this is a polynomial. We're going to attempt the mega property. We're going to take the 2 and plug it into the top. We get a 0. That in of itself is not a bad thing. But when I take the 2 and plug it into the bottom and I get another 0, now I've got indeterminate form. You need to show me that. Okay, you just don't start off on these starting to factor and do stuff. Because I promise you, I'm going to give you a question that you're going to start factoring and doing wonderful things to that you could have just took the number, plugged it in, and got the answer in 2 seconds. And when I give that to you on a test and you spend 10 minutes doing it, and I take it up and I say this should have been done in 30 seconds, you're going to be mad. So remember this. Always, always, always do this first. Make sure that it is indeterminate before you start wasting your time. All right, so factoring method, I look at the bottom, I see a difference of squares. So I assume we all know how to factor difference of squares. X minus 2, x plus 2. That is my 0 term. Notice as x approaches 2, 2 minus 2 is 0. So I've already determined what my 0 term was. I got rid of it before I took the limit. So now I'm taking the limit of something that no longer has a 0 term in the top, no longer has a 0 term in the bottom. So now if I take the limit, I get the limit equals 1 over 4 using the mega property. Put in your equal signs and do not get lazy. If you don't put the limit sign all the way down, then I won't give you the marks all the way down. It's quite as simple as that. You need that limit, okay? What else can I tell you about this? Not much. I think it's fairly straightforward. Look at the next one. Ooh, okay. So I'm going to take x approaching 1. It is a polynomial on top. It is a polynomial on the bottom. I put in 1. I get 2 plus 1 is 3 minus 3 is 0. And I put in 1, I get 1 squared minus 1 is 0. It is indeterminate form, so I have more work to do. So factoring's getting a little bit more interesting. So I'm reaching behind myself and I'm grabbing a scrap piece of paper. I don't care how you factor anymore. I don't want to see your factoring. I don't care how you do it. You just have to do it. So I have a factor. I have to factor a what you guys call a hard trinomial. At BT, we show you something called the Seesaw Method, which is where you put a 2x at the front, you put a 2x at the back, and you put it over top of 2. You're looking for two numbers that multiply to give negative 6 and add to give positive 1. So I'm thinking positive 3 and negative 2. Let's see if that works. These two multiply to give negative 6. That's good. These two add to give 1. This 2 will reduce out of either the top one of them or a little bit out of both. You got to look for it. This is 2x plus 3, nothing common there, but look over here. I can take out a common factor of 2. This 2 will reduce, which means that I can factor that to be 2x plus 3, x minus 1. Let's check it. 2x times x is 2x squared. Negative 2x plus 3x is 1x minus 3. It works. Now, I don't care how you factor. There's also decomposition that many of you use. Great, go for it. Use decomposition. There's also what I started teaching is the crisscross method, which is kind of cool too. I don't care how you factor. You just have to be able to factor. I don't want to see your factoring. I don't want to see the methodology that you use for factoring. All I want to see is this. That's all I want to see. Nothing else, nothing more. Don't muck it up. And so the bottom, x squared minus 1. Now, x squared minus 1 is a factor. It is a zero factor, meaning as x approaches 1, the whole bottom term goes to 0, but it doesn't reduce with my zero factor on top. This is my zero factor. As x approaches 1, this goes to 0. This one doesn't. As x approaches 1, this goes to 5. That's not my zero term. This is my zero term. So I'd really like to get a zero term that's the same as that in the bottom. So it's a difference of squares. So notice there's method to my logic. I'm not just randomly factoring. I know what I need to find. I need another one of these down here. So I'm going to get that by using a difference of squares. That's going to leave me with 2x plus 3 over x plus 1. Now I'm going to use the mega property again. Let's say that again. The mega property. So as x approaches 1, we're going to put 1 in for x, and we're going to get 2 plus 3, which is 5, because it's a polynomial. And 1 plus 1 is 2, last time I checked. And that, ladies and gentlemen, is a very nice answer. That is our limiting value. That's it. That's all she wrote. That's how easy this can be. Next one. So let's do the limit. As x approaches 2 of 2x cubed minus 5x squared plus 3x minus 2. Yeah, now I have your attention. And 3x squared minus x minus 10. So now I have a polynomial on the top and I have a polynomial on the bottom. But the polynomial on top is degree greater than 2, which means that we got to go back and we got to think about our grade 12 function teachers. What did they say? How did they tell us to do it? Oh yeah, there was long division and there was, what was that other one? Synthetic. So you have to be able to do those. But I remember something about a factor theorem and a remainder theorem, and you have to know what numbers to start with. And it was so hard in grade 12 because you had to come up with the numbers. You know what? I can factor the bottom pretty easy. And if I factor the bottom, I'm going to be able to tell my zero term in the bottom. And if I can find my zero term in the bottom, then I know what I need to get out of the top one. So this is in fact easier than what you were doing in grade 12. So let's take a look at this. I've got 3x squared minus x minus 10. It's going to be 3x over 3. Now again, this is the BT way of factoring. There's all sorts of other ways of factoring. Decomposition, what have you. If it works for you, great. I don't want to see it. Two numbers that multiply to give negative 30, but add to give negative 1. I'm thinking negative 6 plus 5. Let's check. Negative 6 plus 5 is negative 1. Negative 6 times positive 5 is negative 30. Yeah, it works. But I got to get rid of this 3. It's not coming out of this one, because that's 3x plus 5. That doesn't common factor. But it does common factor out of here, which means that the factors are 2 minus x and 3x plus 5. Let's check it. X times 3x is 3x squared. 5x negative 6x is negative 1. Negative 10. Man, this is glorious. Because instead of having to do the factor theorem and all that jazz, I now know that my zero term on the bottom, that what I want to get rid of, is this guy. This is my zero term. That's the one that is giving me a problem. As x approaches 2, that's the one that goes to 0. Not this one. That goes to 11. That one's honky-dory. I like him. Don't like him. So I want to get rid of him. So that means that I want to factor this top thing by this binomial. Now I'm going to tell you a secret. I don't remember my synthetic division. And it's not worth it to me to try to remember it. I'm going to do long division because I know how that works. If you remember your synthetic division, go for it. But bottom line, it's not worth it to me to try to remember. So I'm going to do long division here. So I want to match this coefficient. So I'm going to multiply by 2 and I'm going to multiply by x. See, this isn't memorizing. This makes sense to me. So like long division makes a lot of sense to me. So 2x squared times x is 2x cubed minus 4x squared You subtract, so that's going to become negative 5x squared. I want to match this with that, so it's negative 5x. So then it's negative 5x squared. I bring down the plus 3, and this is going to be plus 10x, bracket, bracket, subtract. So that's going to be negative, that's an x, negative 7x minus 2. And I've done something wrong because that should work out to 0. I need to have a 0. So let's see what I did wrong. 2x squared is 2x cubed. And 2x is negative 4x squared. Subtract, that's plus. That should be negative, well, there's my mistake. Negative and negative is plus, so this is negative 1x squared. So that's negative 1 here. That makes this negative 1 here. This makes this positive 2, I think. So now I have negative, negative is positive. This is negative. So that becomes 1x, bring down the 2, and I have plus 1, which is x minus 2, which gives me 0. And notice I knew that I was making a mistake here because I knew that this had to be a factor for my question to work. We good? Now, I sort of stumbled in here, but this is the first time I've done long division in a year and a half. So, I won't stumble my next time, okay? And you guys need to, you're going to make mistakes, fix it up, and be more proficient for your next one. So, bottom line, this becomes limit. As x approaches 2, the top factors out to x minus 2, 2x squared minus x plus 1. I don't really care at this point if this factors anymore. Okay? It's not really important to me because notice my 0 term is going to cancel, which means I've now got rid of a 0 in the top and a 0 in the bottom. So as long as when I do mega property and I put it in, I don't get 0 over 0 again, I'm good to go. Now, if I did get 0 over 0 again, guess what I'd do? Look for another 0 factor and try to reduce it out. This could go on and on and on a couple of times. You could have more than one 0 factor in it that you need to get rid of. But in this case, as I allow x to approach 2, I'm going to get 4 times 2, which is 8. I'm going to get minus 2 plus 1. And the bottom's going to be 6 plus 5. So it's going to be 6 plus 1, which is 7 over 11. Ooh, 7-Eleven. I like their Slurpees. They're good. Yum. Okay, there's a question. I'm going to pause the video here and we'll be right back.